Then we have seen certain set of rules, key points that is to be noted for a perceptron network. This we have seen. The output of perceptron network is given by y equals to f of yn and the activation function, where f of yn is what? It is the activation function. Here we are using a bipolar step function. You can see for that function equal to 1 when y in is greater than 0. When the function is in between minus theta to theta, the output will be 0. And when it is minus 1, when yn is less than minus theta. Okay. Then this is the perceptron network. You can see this is the sensory unit. The first part is the sensory unit. It's having the sensor grid around 400 units of sensor grids are present, which can be represented in a two-dimensional space. So two-dimensional space consists of 400 sensory unit or sensor grid. So it consists of two-dimensional matrix. You can see there is a matrix in a sensory unit which is consisting of 400 photo detectors. And these photo detector, when it will be activated, when light will be uh, present on that particular photo detector. So this all 400 photo detectors will be activated, and it will be consisting of जो cross दिख रहा है, that will be consisting of black and white pattern. So जो cross है, that is black, and a space, it's known as a white pattern. So these detector will provide a binary signal 0 if the input signal is found to exceed some threshold value. Okay, so when this sensory unit will become binary 0 when the detectors are active, and they provide an electrical signal if the input signal is found when it will reach the threshold, or it will reach or exceed the certain value of the threshold, the detectors will provide the binary 0 of an electrical signal. Then after that, these detectors are connected randomly. All these detectors, you can see they are connected randomly to the associator unit. This one is the associated unit. So they are connected. The sensory unit are connected at a random to the associated unit. And the associated unit is consisting of sub-circuit, which is also called as feature predicates. So it will predict the features of a particular data set that is present at the input side, and there are set of different sub-circuit present in the associated unit. Okay, so these detectors are connected randomly. So all these 400 detectors are connected randomly to the associated unit. And what associated unit consists of? It consists of many sub-circuit which is used to predict the feature. So they are called as feature predictors. Then the feature predictors are hardwired. You can see all these things are hardwired to detect specific feature of the pattern, and these are also known as feature detectors. So feature predictors and features detector. So they are the same thing. They can either predict or they can either detect. So suppose for a particular feature, each predictor is examined with a few or all the responses of the sensory unit. So they can examine all the response of the sensory unit by using predictors. And the last unit is the response unit. So response will provide a particular pattern recognizer or a perceptron. So this will be consisting of a pattern recognizer. They will recognize some pattern which is available from the input side to the associated unit. So the weights that is present in the input layer are all fixed. So all these weights are fixed that is present in the input layer, and the weights that is particular weights CA W1, W21, W22, all these weights are responsible for training purposes. ठीक है, तो perceptron में क्या होता है, the weights that is present at the input end are fixed and the weights which is connected to the response unit are trainable. Okay, you can change this type of weights. So this is the perceptron learning rule. Now, what is the perceptron learning rule? So the learning signal is the difference between the desired and actual response of a neuron. Okay. So what does this mean? What is the difference between the desired and actual response? It's known as the error जो हम लोग जो feedback में देते हैं. So that is a learning signal. From this, the input or hidden layers of the neuron can learn by giving the using the input of a error signal. So learning signal is what? It's a difference between desired and actual response of a neuron. Then what learning steps are there? So consider a finite n number of input training vectors with their associated target or desired value, which is considered as x of n and t of n, where n ranges from 1 to n. Okay, so the first learning rule, what we need to learn first, we need to consider a finite number of input training vectors. Okay, so all these training data will be in vectorized form with the associated target. मतलब हमने जो कल OR gate and gate वगैरह पढ़ा, what we are doing, we know the input as well as we know the output. So for one AND gate, the output should be one. So all this thing is known to the programmer. So we need to consider a finite number of input training vector with the associated target or the desired value. Xn and Tn they have given, where n ranges from 1 to n. So the number of inputs or number of input training vector, you can range it from 1 to capital N. The target is either +1 or -1. So you need to set a target either positive or negative. Then the output Y is obtained on the basis of net input calculated. So how we calculated the net input yesterday? Summation of xi into wi. We multiplied or the weighted sum we have taken to calculate the net input. And then we have applied an activation function. Activation function अभी तक हमने apply नहीं किया, but after that the activation function is being applied over the net input. So this is the perceptron learning rule. Then the third step. The output y that is obtained on the basis of net input calculated, we applied over the activation function. So, what is the activation function? We have, suppose we have used a bipolar activation function. Okay. So this is the formula, or this is the range for the bipolar activation function. And then the weight updation, if it is required for perceptron learning, then weight updation, the new weight, that is W of new, will be calculated as W old, that is the old weight, plus some learning rate that is being used, that is alpha into Tx, and in bracket alpha minus learning rate. So all these things is given, alpha is constant and Tx is the output or the net input. Now the weights can be initialized. We have W new equals to W old. Suppose if Y is not equals to T, then we can use the W new, the first one case. And if Y is equal to T, what is Y? Y is your this function wala, activation function wala Y. If Y is equal to T, T is the net input, then you need to use W new equals to W old. अगर Y equals to T है. If there is an error, then use this first wala case to update the weights properly. Now, this is the architecture for a single classification problem, perceptron network. ये सेम थिंग है यहाँ पे x0 which is multiplied with the bias b, x1 is multiplied with w1 plus x2 is multiplied with w2 and xn is multiplied with wn. So this is x1, ये xi है शायद, and then there is xn. And what will be the output y? Y is equals to b into x0. यहाँ पे x0 उसने 1 दिया है, so it will be only b plus x1 w1 plus x2 w2 plus x3 w3, likewise xn into wn. Okay, so this is the architecture of single perceptron network. So this is original architecture or a simple perceptron network where the output obtained from the associated unit, the middle one, that is hidden layer, is a binary vector. So we have already seen the output obtained by the hidden layer is a binary vector. So it can be 1001 like this. And hence the output can be taken as the input signal to the response unit, right? So if this is a hidden layer, and this is why this is the output of the associated unit, which goes as the input signal to the response unit, and the classification problem can be performed. So what is the classification problem? It is a binary signal, whether input data is male or female, or input data is cat or a dog. So binary में जो भी classification हो सकता है, it is done through this type of a simple perceptron. So here the weights between the associated unit and the output units can be adjusted, and the weights between the sensory and the associated units are fixed. So this I have told you earlier. The weights between the associated unit and the response unit is being updated, and the weights between the sensory unit and the associated unit are fixed. Okay. Then so the associated unit for such a case will behave as an input unit to the response unit or the output unit. So in this figure, there are n input neurons, one output neuron, and a bias B is there. So the input layer and output layer are connected through a direct communication link, and which is associated with the weight. So input layer and output layer is directly connected with the help of your weights. And goal of the perceptron is what? Goal of the perceptron is to classify input pattern. It's a member of that particular classification or not a member. ठीक है? Whether that particular data is male or not, female. So it will give only the binary classification. So the perceptron network will use this classification problem to classify the input pattern. Okay. Now you can see the training process of Perceptron network. So this is the single output class for a single output. So Perceptron training starts with initializing the weight and initializing the bias. ठीक है? So the perceptron algorithm can be used either for a binary or bipolar input vector. So there are bipolar targets or threshold which are fixed, and there is a variable bias. So so this algorithm is not particularly sensitive to the initial value of weight or a learning rate. So they are not sensitive to the initial value. So whatever the input is being applied, or whatever the initial value of the weights or value of the learning rate is being inputted or given to that particular uh, block. You can see this first block, or you can say the sensory unit. It is not sensitive. So initially the inputs are assigned, and then the net input is calculated. Okay. So this net input, how you can calculate? By taking a weighted sum of input and a weights. So first stage is initialize weight and bias. Set alpha. Alpha is your learning rate. It can be a binary or bipolar target, -1 or 2 plus 1, or it can be a binary 0 and 1. Now for each input and output, for each input and output, you can give the activated input units. So we need to give some of the activation functions. So suppose we take a bipolar activation function. So it will imply whether the uh, input is similar to your actual input. Predicted input is similar to the actual input. If it is yes, then it will calculate the net input y in. Now this, after calculation of net input, it will again apply the activation function y is equals to f of yn. And if y is equals to t, y is not equals to t, then if this function is if the function is true, then it will go to this block and it will update weight according to wi new is equals to w old plus alpha tx, and also bias will be updated by adding the learning rate, and the net input. Okay. And if this condition is not satisfied, it will go here in this block. That is, the new weight will be equal to old weight, the new bias will be equal to old bias. ठीक है. ये कब होगा? When y is what? Your net input is not equal to t. T, that is your output. Then after this, if the weights are changed, yes, the weights are changed, then go to the first block again. Again check for the input and again calculate the net input. Whatever the error was there, it should get reduced after some of the iteration. तो ये iteration of loop जैसे जैसे आप बढ़ाओगे, your accuracy will be increasing. ठीक है. If there is no weight change, it will stop that particular iteration. Okay, in this flowchart, do you have any doubt?
No, ma'am.
Okay, I'll again teach you this flowchart. सबसे पहले step zero is what? You need to initialize the weight and the bias. Okay, so for easy calculation, what we can do, we can set that to 0. We can initialize that particular weight and bias to 0, and then initialize the learning rate alpha. So alpha is between 0 and 1. So alpha is what? It is a learning rate. We need to initialize it into between 0 and 1. ठीक है. In between whatever you want to set the value, you can set the learning rate. And for simple reason, we set this learning rate to 1. Then till the stopping condition is reached, you need to enter the loop and iterate the loop. Okay. The input layer for each training pair, that is indicated by S and T. So S is your sensory unit, T is the output unit. And now we need to activate the input unit. So suppose this condition is reached when S is holding some of the input values, and xi, that is your input unit, is applied with some identity activation function, then xi will be equal to si. Okay, the input layer is what? It is the sensory unit. If it is containing some input unit that has been applied with the identity activation function, then xi will be equal to si. Then output of the network is to be calculated, that is yin. Yin is what? Equal to b plus summation I equals to 1 to n xi and wi. Okay. Okay, so after applying the activation function, y is equals to f of y. एक सेकेंड, just a minute. Okay, so this block is the conditional block where we check the input data as with the output data. So if it is required key y is not equals to t, then we should update the weight. If y equals to t, that is input and output data is matching, so we should not update the weights as well as the bias. So if it will again check if the weight changes, then again go for the iteration and apply all the activation function and update the weight. And if there is no weight changes, it will stop the process. Is it clear now?
Yes, ma'am.
Okay, now what we'll do, we'll see one program based on the neural network. So simple neural network we'll design. So this is the input or one of the example. So example one is this: if input given to the sensory unit is 001, the output should be 0. If it is 110, ये कोई x और वगैरह ऐसा गेट नहीं है. It's just input that is the actual input and the predicted output. So 111 output should be 1, 1011 and 0110. And we'll check for this key what happens if the input is 100, what should be the output. Okay. You can see this Google Colab.
No, ma'am. No, ma'am. No, ma'am.
एक minute. Is it visible now?
Yes, ma'am.
Google Colab is visible.
Yes,
Yes.
ma'am.
Yes,
Okay,
ma'am.
what is our input? ठीक है हमको क्या करना है 001 the predicted output. So what we are feeding the neural network with input as well as output. So this is hard coded कि ये input है तो output यही आना चाहिए. देन आफ्टर कि इनपुट ही देंगे हम लोग क्या करेंगे इसको ट्रेन करते रहेंगे कि अगर 001 है तो आउटपुट 0 आना चाहिए 11 है 1 है सो व्हाट द मॉडल विल डू इट विल ट्रेन बाय इटसेल्फ एंड वो लूप में घूमता रहेगा उसकी वेट्स एंड ऑल दोस थिंग्स विल गेट अपडेटेड एंड आफ्टर दैट इफ वी गिव अ न्यू सिचुएशन तो उस हिसाब से अपना न्यूरल नेटवर्क जो है जो ऑलरेडी उसके दिमाग में थोड़ा बहुत कैलकुलेशन फिट होगा कि अगर ये चीज आती है तो उसका आउटपुट क्या रहना चाहिए नाउ फॉर दिस न्यू सिचुएशन आई विल टेल यू द आउटपुट शुड बी 1 ठीक है तो द प्रिडिक्टेड आउटपुट बाय द मॉडल शुड बी 1 दैट इज 100 and the output should be what it should be 1 ठीक है so we'll see in this Google Colab how we can write तो सबसे पहले हम लोग क्या करेंगे initializing the weights ओके इसको बस ये कैसे लिखते हैं वो ध्यान मत दो इसने कैसे लॉजिक लगाया वो बताती हूँ बाकी ये सब तो फंक्शन एंड ऑल दोस थिंग्स है यू कैन डू इट बाय योरसेल्फ सो यू नीड टू import a numpy library so numpy library is generally used can anybody tell what is numpy library अभी तक आपने पाइथन वगैरह सब सीख लिया है what
For
is numpy
for fast processing of numbers.
no numpy is generally used for mathematical function or to generate some random number some linear algebra type maths Fourier transform so numpy is used for numerical operation ये library है it is not for fast processing or like that it is used
My
yeah for linear algebra type mathematical functions matrices आपको अगर करना है या फोरियर ट्रांसफॉर्म निकालना है तो यू यूज दिस लाइब्रेरी numpy अगर आप उसके इसमें जाओगे numpy.org you can see what are the different calculation you can perform so maybe it's when you use this particular type of library by this the mathematical function become fast or processing becomes fast so we import this first library because we have the mathematical equation to be performed so mathematical function में हम हमारे पास क्या है परफॉर्म करने के लिए the activation function हमको लगाना पड़ता है यहाँ पे आई एम यूजिंग अ सिग्मॉइड एक्टिवेशन फंक्शन ठीक है एक तो ये मेन टाइप का फंक्शन डिफाइन किया है वेयर np डॉट रैंडम डॉट सीड नाउ np डॉट रैंडम व्हाट इट विल जनरेट सम रैंडम नंबर्स वो जनरेट करेगा लेकिन सेम सेम नंबर अगर मुझे चाहिए तो आई विल गिव सीड ऑफ 1 मींस व्हाट रैंडम अगर हमेशा अगर इटरेशन चेंज होता है सपोज आई एम गिविंग 1000 ऑफ इटरेशंस ये प्रोग्राम 1000 बार चलेगा लूप में तो क्या करेगा ये तो रैंडम नंबर जनरेट करने ही वाला है बट इफ आई गिव दिस सीड इट विल have the same number for many iteration ठीक है सपोज वेट्स के उसको नंबर्स देना है तो फॉर W1 इफ रैंडम नंबर जनरेटेड 0.5 W2 के लिए रैंडम नंबर जनरेटेड 0.6 तो हमेशा ये इटरेशन में 0.5 एंड 0.6 ही लेगा रैंडम नंबर्स वो नहीं रहेगा नहीं क्योंकि हर बार इटरेशन में अगर np डॉट रैंडम लिखती हूँ तो वो रैंडमली जनरेट करता जाता है. सो W1 एंड W2 वेट्स आर रैंडमली अपडेटेड. ठीक है, तो मुझे ये नहीं चाहिए. आई वांट अ फिक्स वेट. जैसे मैंने अभी बोला, फ्रॉम सेंसरी यूनिट टू द एसोसिएटेड यूनिट द वेट्स आर सेम. ओके, नाउ यहाँ पे आई एम कन्वर्टिंग द मैट्रिक्स, converting weights to a 3 by 1 matrix with the value from -1 to 1. So this will also generate some of the random numbers which will be from -1 to 1. जैसे हमारे bipolar step function के लिए what it is, if it is less than theta and it is greater than theta, it is in between 1 to -1. So this particular variable will hold some of the random values. Okay, then I am applying a sigmoid function. ठीक है, ये sigmoid नाम का एक function दिया which is taking the input from self, this one. Okay, and then 1 upon 1 plus e raised to power minus x is what? It's your mathematical function for sigmoid. So the activation function which I am using for developing the neural network is sigmoid. ठीक है, क्योंकि मुझे कर्व कैसा चाहिए, फ्रॉम -1 to +1, right, in the shape of S type. So it should be gradually increase the iteration. And then after I'll be computing the derivative of the sigmoid function. Why I want a derivative? Because it should be from 0 to 1. Now what all these things are doing, now I'll be giving some training data set, and this training data set I'm taking the input and training iteration. So training iteration यहाँ पे is available. अगर मुझे 1000 ट्रेनिंग इटरेशन देना है, now see here, इसका ट्रेनिंग इटरेशन कितना है, 15000. ठीक है, तो ये कितनी बार चलेगा ये लूप, 15000 बार. सो यू कैन चेंज इटरेशन, आप कम या ज़्यादा कर सकते हो, सो डिपेंडिंग अपॉन द आउटपुट. ठीक है, सो द मेन थिंग यहाँ पे इज व्हाट, दिस वन 001. नाउ हमारा इनपुट डेटा किधर गया, 001, द आउटपुट शुड बी 0. तो ये क्या लिखा है मैंने, एक एरे में लिखा है, np.array. So this will be consisting of array, जैसे 001 matrix है, 111, 101, 011, and the training output also I am providing in type of array. So 0, 1, 1, 0. So this is your training output. ठीक है, यहाँ पे देखो. ठीक है, तो ये क्या है, ट्रेनिंग आउटपुट 0110, एंड ये सारे इनपुट आई हैव रिटर्न इट इन अ array. Now I am transposing these two array. Dot t मतलब क्या, I am taking a transpose of this np dot array. ट्रांसपोज मतलब क्या, ये क्या है, अभी रो एरे है, मुझे इसको वर्टिकल करना है. तो आई एम ट्रांसपोजिंग दिस आउटपुट, and then I'll multiply this input with the output. Now यहाँ पे the training will take place. I'll run this code. So this neural network, a neural network is a class already defined in this library. So after this, it will begin randomly generating the weight. ठीक है, अभी तक ये घूम रहा है, मीन्स 15000 इटरेशन इट विल ट्राई टू परफॉर्म. Till then, just give your attendance. Okay, roll number 1. Give your attendance. Roll number 2. Roll number 3.
Yes, ma'am.
Roll number 4.
Present, ma'am.
Roll number 5.
Yes, ma'am.
Roll number 6.
Yes, ma'am.
Roll number 7. 8.
Present, ma'am.
9.
Yes, ma'am.
10.
Present, ma'am.
11.
Present, ma'am.
12.
Yes, ma'am.
13.
Present, ma'am.
14.
Yes, ma'am. Present, ma'am.
15.
Present, ma'am.
16.
Oh, ma'am, I am 16 present. I don't know who 15 is.
15. Rohit Jha is there. Then 17. Vivek. 18.
Present, miss.
19. 20.
Present, ma'am.
21.